Subscribe to AmpCode and ring the notification bell to get the latest content.
Hello and welcome back. In the previous lecture, we have seen all about the overview of MLlib library. So in this lecture, let's talk about why we are using MLlib library with Apache Spark, because there are several tools in the market right now which gives you the capability to run machine learning algorithms on top of your big data. But Spark has its own advantage. So basically, as you already know, MLlib will provide you a robust platform for efficient big data analytics. Efficient means, since as you already know that Spark architecture relies heavily on the parallel data processing. Parallel data processing means your data workloads are get splitted up and converted into smaller chunks of tasks and get distributed across the clusters, and the cluster nothing but consists of the data nodes, which are nothing but the commodity hardware, which runs parallelly to complete the workflow in a very efficient manner. So basically, big data means the data which is coming in higher velocity, veracity, as well as the volume. So to handle that, Spark will give you the capability to work with different sorts of data, like the real-time data as well as the batch data coming at higher volumes. So MLlib library is nothing but a high-level API built on top of the Spark core API, which gives you the capability to run different sorts of algorithms, which are nothing but the regression algorithm, classification, dimension reduction, as well as the clustering and the rule extraction. So these are some of the popular machine learning algorithms which are used in many use cases out there, and MLlib will give you the capability with the added benefits. Let's talk about the benefits now, then we can move ahead to the hands-on part. So the first one is the ease of use. So basically, as you already know, we can write Spark application in various languages, which are nothing but the R, Scala, Java, as well as Python that we have seen so far in our series. So basically, any developer which is only proficient in some language can easily work with Spark, because it gives you the capability to work with all sorts of languages with some syntactical differences. But also, if we talk about the data sources, Spark will allow you to connect to multiple data sources. Let's say if your data is there in the RDBMS, which is nothing but the relational databases like the Oracle or the MySQL, or else your data could be present in the raw format in some S3 bucket or some flat files. So Spark will easily integrate with this data and builds data frame on top of it, and that could be the starting point of your machine learning pipeline, which is nothing but the input to your machine learning pipeline. As well as Spark will integrate well with NoSQL databases as well, which can read the data from various NoSQL databases like the Neo4j graph database. Then we have the MongoDB document based database and the very popular and lightning fast Cassandra database, which we are going to see in the subsequent lectures as well, and how to integrate with the pyspark. So basically, due to these capabilities, you can run your machine learning algorithms on all sorts of data. So let's say if your organization have different type of data related to different asset classes present in different sources, and also these different sources can have like different formats. Your data could be present in a CSV format, it could be present as a document, which is nothing but the JSON format, as well as your data could be present in the flat files. You can integrate them well with Spark and run your machine learning algorithms with ease. You just have to read the data and store it as a data frame, and that data frame can be input to your machine learning algorithms that we have just discussed. Also, Spark fits well in the Hadoop ecosystem as well. So it can use HDFS as a storage layer, Yarn as the resource negotiator. So you don't have to worry about all the administrative tasks that you have to do in some other tools, because other tools may not give you this capability and that level of integration with the other data sources as well as the data sinks. So as you can see, the first one is the ease of use. So that's why using your machine learning, deploying your machine learning pipeline in Apache with Apache Spark is a way to go. So the next benefit is the performance it brings on the table. So as you already know that Spark excels at the iterative computation, which is nothing but beneficial for your machine learning execution and all the transformation and actions you are applying on top of the data frame. So basically, due to this iterative computation capability, Spark MLlib library have the algorithms which belongs to the MLlib library will work faster than any other platform out there. So that gives us the capability to run your machine learning pipeline very efficiently across the cluster. And as you already know, we have talked about the architecture of Apache Spark, which is nothing but works in parallel and a distributed manner, which again boosts the performance of your machine learning pipeline with ease. And you don't have to worry about many administrative tasks. There are some settings and configurations that we are going to see subsequently to improve the performance of your machine learning pipelines. You can use all sorts of best optimization techniques to again boost the performance of your application. You can use caching, persisting strategies as well, and as you already know that Catalyst Optimizer will give you the more optimized execution plan for your application. So that's why using MLlib library than any other tool is a way to go. The next one is it runs everywhere. So as you already know, Spark is not tied to any other tool like Hadoop. It utilizes Hadoop as its storage layer, so it can utilize HDFS as its storage layer. But it can also run standalone. So there are different deployment modes of Apache Spark, and it can also run on different cluster managers. So there are several cluster managers and it has their own pros and cons. So Spark can utilize the cluster manager of Hadoop, which is Yarn, which is nothing but yet another resource negotiator, which we already talked about, to manage the resources of Apache Spark cluster. But it can also run with other external resource negotiators, or we can say resource managers like the Mesos. Then we have the Kubernetes. So it totally depends on what type of solution your organization is using and what type of data platform it has. So let's say if your organization is already using Kubernetes for your data solutions across the entity, then you can definitely integrate it with the Kubernetes. Because Spark runs as a standalone as well as on any other resource negotiator. So due to these integrations, it is a pretty versatile tool for handling big data as well as running your machine learning algorithms on top of this data. So this is all about why we are using machine learning with Apache Spark and not any other tools out there. Let's also talk about some of the cons of using machine learning with Apache Spark. So one thing is computationally expensive. So this is not applicable to all the applications out there. There are some applications which uses the complex data set where we have like the complex column data types, which is nothing but nested in the nested forms or in the array forms. So to able to run all the transformation and the algorithms on top of those type of data, it could be computationally expensive. And the second one is nothing but due to this complexity, it consumes a large amount of resources across the cluster, which increases your cost of running your application on the Apache Spark cluster. So let's say if your machine learning pipeline is hosted on any cloud platforms out there like AWS, Azure, then the cost of running your machine learning pipeline totally depends on how much resources you're consuming to run your application. So let's say if you're handling data which is kind of complex, then it consumes a lot of resources, and in result it will increase the cost of your pipeline. And the next one is the lack of security. So since we are using RDDs and data frame, that data is present in an unencrypted format. That's why any sensitive information like the customer's PII information or the transactional details or any sensitive information like the healthcare or the medical records, then that could be a potential risk for handling such sensitive information in Apache Spark, because it does not give you the encryption capability out of the box, and handling those kind of data would not be a good choice for Apache Spark. So these are some of the cons of using the machine learning library in Apache Spark. So in the next lecture, let's go through the step-by-step approach of how you can build the machine learning application with Apache Spark.
So that's it for today. I'll see you in the next lecture.